Okay, good evening everyone, and today we are going to learn electricity, continue with electricity, question 6, question 6, question 6, page 6, this page, this question, this page, this booklet, okay, question number 6, question number 6, what is the first question? Figure 6 point shows an emission heater rated 240 volt and 2 kilowatt. 2 kilowatt. Explain what is meant by the label 240 volt and 2 kilowatt. I already explained to you that is we call it the label. Okay, label. Okay, when you plug the electrical equipment, when they plug the power, okay, there is a small sticker that's called voltage, the power, the current, or sometimes resistance or frequency. They put label. So what is the label? Okay, what is the answer for this question? If the heater connected to 240 volt, the answer like this. If the heater connected to 240 volt, the energy would be 2000 joule per second. Okay, you cannot say the power. Okay, actually they say the power 2 kilowatt. 2 kilowatt is a 2000 watt. 2000 watt is a 2000 joule per second. Watt is joule per second. Okay, so the answer is this one. The answer is that is, if the heater connected to 240 volt, the energy should be 2000 joule per second. 2000 joule per second. You cannot mention 2 kilowatt, but we derive 2000 joule per second from 2 kilowatt. So 2 kilowatt means 2000 watt. 2000 watt means 2000 joule per second. Okay, that is the meaning of rated. That's the meaning of the label. Next question: the heating element of the immersion heater nichrome. Give a reason why nichrome is used. Why nichrome is used? Okay, there's many reasons for nichrome. Because high resistance. So high resistance, when you connect with high resistance, it can produce heat. Because the heater is supposed to produce heat. So high resistance, and there's another the answer. So the correct answer, high resistance I accepted. High melting point, because high melting point, and cannot be oxidized easily. High melting point and cannot be oxidized easily. That's what we call it. Okay, cannot be oxidized easily. And question number C: if the immersion heater is connected to 240 volt supply, calculate the current that passes through the heater. Current. So P equals to IV. So the power equals to 2000 watt. The 2000 watt, 2 kilowatt, 2000 watt. The power is 2000 watt and equals to IV. Okay, and I just little bit. Okay. Okay, you can see now. You can see my face now. Okay, 2000 watt and voltage is 240 volts and 2000. So I equals to 8.33. 28. Sorry. You can find 2000 divided by 240. Is 8.33 something. Is it 8.33? Okay, then you can find the current lah. Okay, you can find the current 2000 divided by 240. And next question, question number D. Calculate the resistance of the heater. Resistance of the heater. Okay, the current is correct. 8.33 lah. The current is correct. 8.333 ampere. Okay, and the resistance. Question D. Question C. Question D. V equals to IR. The voltage 240, the current is 8.33 and R. So R divided by 240 is a 28.8 lah. 28.8 ohm. That is the resistance equivalent. The resistance of the equivalent. Question E. If the immersion heater connected to if the immersion heater is connected to under 10 volt supply, what will be the heating power of the immersion heater? That's question. Okay, we have to use this one. For example, P equals to IV. The current is 8.33 and the voltage under 10 volt. So if you get this one, you get 916 watt, 960 watt. But this is not answer, correct answer. This is not correct answer because there's a change in voltage. Change in voltage. That's not 8.33. We got 8.33 current by taking voltage 240 volt. By taking the voltage 240 volt. But now we are taking under 10 volt. So it's not 8.33 current. So we cannot use this formula anymore. So we have to use another formula. P equals to V square our R. So this you remember last class or previous class, I told you we must use this formula when there is a change in voltage. We have to use this formula when there is a change in voltage. So voltage is under 10 volt square and R is 28.8 lah. So under 10 volt square. Under 10 volt, the resistance will never change. Resistance of the equipment, wherever whatever voltage will change, the power will change, the resistance is a fixed resistance in the factory. The factory they fix resistance. So the fixed resistance 28.8. Okay, the resistance cannot change. So under 10 volt. So then power is equals to 420 watt. 420 watt. So what is the benefit? Okay, what is the benefit? Okay, if power is 400, okay, I will this question, there's one question, I think I saw this question, one past question or trial questions somewhere, some previous years, some question and they asked about this. Okay, if 420 watt, what is the benefit? What is the benefit? If under 10 volt, in the same heater, suppose be connected with the 240 volt. Suppose be connected 240 volt, but the heater is connected with under 10 volt. So the power is reduced to 420 watt. But if the 240 volt, if the connected 240 volt, if it's 240 volt, the power will be 2000 watt or 2 kilowatt, 2 kilowatt as mentioned the label, 2 kilowatt. So if when you get in order to get 2000 watt power from the equipment, 2000 watt power from the equipment, from the heater, you have to connect 240 volt or 2000 joule per second energy, 2000 joule. So every second it releases 2000 joule energy, heat energy. Every second it produces 2000 joule heat energy. When heater is connected 240 volt. But this one, the heater is connected under 10 volt. Under 10 volt. This heater, the same heater, is connected under 10 volt. 110 volt, the power is very less, 420 watt only. 420 watt or 420 joule per second only. So what is the benefit? This one is 2000 joule per second. Okay, can you understand. Heater, the same heater connected 240 volt, the heater connected 110 volt. When heater connected with a 240 volt, the energy release is 2000 joule per second or 2000 watt. Here, when the heater connected 110 volt, the energy release is 420 joule per second. 420 joule per second or 420 watt. So, what is the benefit? So, same heater. Okay. So, the benefit or disadvantage. Disadvantage is this one will, if you boil the water by heater, by using heater, you boil the water, it will take longer time to boil the water because it's 420 joule per second only. But this one, the water boils faster because 2000 joule energy, joule per second. So that is a benefit. This is a benefit. So you can boil the water faster. This one boil the water slower. That's the benefit. Okay. And we're going to do another question. We're going to do the question number 7. Question number 7. Question number 7 today. We're going to learn some questions. Okay, figure 7.1 and 7.2 shows two situations of the same circuit which conductor R is connected to rheostat. The battery is 7.1, rheostat adjusted to voltmeter 2.8 volt, 7.2 rheostat adjusted to voltmeter 3.6 volt, and the ammeter circuit is read 0.56 and 0.72. So in a 7.1 the voltage is equals to 2.8 volt and the current equals to 0.56 ampere. So 56 ampere. In 7.2 the voltage equals to 3.6 volt and the current equals to 0.72 ampere. So voltage increase, current increase directly proportional. So the question is, what is meant by electric current and electric potential difference? Electric current, the rate of flow of electric charge. Okay, we learned before. What is electric current? Rate of flow of electric charge. Okay, and what is the potential difference? Work done to move a unit charge in electric field. Work done to move a unit electric charge in electric field. Using 7.1, 7.2, compare the value of V or I of the conductor of the two circuit and the voltage across the conductor and the current through the conductor, deduce the relevant physics concept. So, in 7.1, V or I. So, V equals to 2.8 and 0.56. So, V or I equals to 5. In 7.2, V or I also 3.6 and 0.72. So equals to 5. Okay. 2.8 divided by 0.56. 3.6 divided by 0.72. 5. Okay, V or I is equals to R, resistance. So resistance is R. V or I equals to resistance. V or I equals to R. R equals to 5 ohm. R equals to 5 ohm. So the resistance is equal. Okay. What is the concept? Figure 7.1, 7.2. Compare the V or I, the conductor in the two circuit, relating the voltage across the conductor and the current through the conductor, reduce the relevant physics concept. Okay. The concept is, when the voltage increases, the current increases. When the voltage increases, please listen to me. 2.8 to 3.6. When the voltage increases, current also increases. But however, the V or I equals to R equals to 5 ohm is a constant value. The resistance is constant value. Okay, the resistor is a constant because we can get 2.8, 0.56, 5 ohm. 3.6 divided by 0.7 is 5 ohm because the circuit is same resistance. Same resistance. The circuit having the same resistance. Only thing they arrange, they adjust the voltmeter, or sorry, adjust the rheostat for the increased current, increased voltage. So the resistance is same. So resistance is same. So resistance constant value 5 ohm. That is a concept. Question number 3. Name the physics law that explains the above situation. Ohm's law. Voltage increase, current increase. Ohm's law. Directly proportional. Voltage directly proportional with current. Okay, Ohm's law. State the relationship with the length of the wire and the resistance of the wire. Length of wire and the resistance of the question number B1. Question B1. The length. Resistance directly proportional length of wire. So we must say, you cannot say directly proportional, no, you must say like this. And when the length of wire increases, the resistance increases. When the length of wire increases, the resistance increases. When the length of wire increases, resistance increases. Question number 2. And question number 2, state the relationship between the cross-section area of the wire and the resistance of your wire. So the R is the cross-section area. So R directly proportional L. L means length of wire. R inversely proportional with the cross-section area wire. So the cross-section area wire increases, the resistance decreases. So when the cross-section area of the wire increases, the answer is the cross-section area of the wire increases, the resistance decreases. Resistance decreases, inversely proportional. Question number C. The diagram shows a circuit of 2 ampere. In circuit 2 electric resistor connected to parallel. Calculate the I1, I2. Okay, this question. This question. This is 12 ohm and this is 4 ohm, and the I is equal to 2.0 ampere. So this current, this question is a shortcut and long way, okay. But I teach a long way first. So to teach a long way first, we have to do this. We have to connect this one. Connect to the battery. Okay, the voltage to the battery. So to find we have to find the voltage of the battery because it's parallel resistance. Voltage of the battery. To find this one is I1 and this one is I2. I think I1, I2. I1, I2. Because this current is splitting. This is I. Total current is flowing I. The 2 ampere flowing and the current split in I1, I2. So this long way. To find the long way, you have to find the total resistance first. To find the total resistance, 1 over RT equals to 1 over 12, 1 over 4. This is a parallel resistance. So 1 over RT equals to 4 times 3 plus 1, 4 over 12. 4 times 3, 12, 3 plus 1 is 4 over 12. Reverse RT, 12 over 4. So this is 12 over 4 is RT equals to 3 ohm. RT is 3 ohm. So total resistance 3 ohm. Total resistance is 3 ohm. Okay, the total resistance is 3 ohm. So total resistance 3 ohm. What is the total voltage of the battery? Total current is the main current 2.0. So 2.0 ampere the current. So we have to use the IR. So all T. total voltage, total current, total resistance. All this is the circuit. Total voltage from the battery, so V. Total current is 2.0, 2 ampere. Total resistance, that's now you found from parallel resistance. Total resistance is 3. So the V equals to 6 volt. So the V equals to 6 volt. The V equals to 6 volt. So the V equals to 6 volt. So shortcut is a long way is we find the total resistance first. We find the total resistance first in order to find the total voltage. In order to find the total voltage, because we have to find the voltage at the 12 ohm. Okay. Now we have a voltage 6 volt. So the parallel resistor we learned before. The voltage here and here must be same. The voltage here and here must be same. Same voltage. So the voltage 6 volt, V12 ohm, V4 ohm equals to 6 volt. 6 volt, because parallel resistance, there's no combined. Combined means series and parallel together, but this is parallel only. So the voltage here 6 volt and 6 volt. So voltage 12 ohm is 6 volt and voltage 4 ohm is 6 volt. Voltage 12 ohm is 6 volt. Voltage 4 ohm is 6 volt. Okay. Now we have to find the current I1. The current I1. So V equals to IR. So V 12 ohm. Small 12 ohm. We write small 12 ohm. Or we write V1. V1 6 volt. V2 is 6 volt. So this is R1. R2. We can put R1, R2. Okay. But we have to find the V12 volt or 6 volt. So the V12 ohm is 6 volts. I1 R1. I1 R1. I1 R1. That is called voltage here. The voltage here is maybe 6 volt. I1 R1. So the I1 is we don't know. The R1 we know 12. So I1 equals to 6 or 12 0.5 ampere. I think so. 0.5 ampere. V4 ohm equals to 6 ohm. So 6 volt. So V4 ohm, I2 R2. V4 ohm, that means voltage at 4 ohm resistance. Voltage 4 ohm resistance. Or V2. Or V2. Or V2. V2. So we call it V2. So 6 volts. I2, the current I2. R2, the resistance 4 ohm. So I2 equals to 6 divided 4 is 1.5, I think so, 1.5 ampere. So our working is correct because this is 0.5 ampere, this is 1.5 ampere. So 0.5 and 1.5 you plus this must be same as total current. The split current 0.5 plus 1.5 is equal to 2 ampere. So our working is correct. There's one method, there's a parallel method to prove working is correct by taking the total current. Total current must be, so the total current I equals to I1 plus I2. So the I is 2 ampere, I1 is 0.5, I2 is 1.5. So 0.5 plus 1.5 is 2 ampere. So it's equal to 2 ampere. So that's working lah. And we're going to learn now. We're going to learn the next question. What is the potential difference across 12 ohm resistor? 12 ohm resistor. We are asking 12 ohm resistor. Potential difference. What is the potential difference? Potential difference voltage. Na? The voltage 12 ohm resistor. I2, so I1, R1. I1, R1. So I1 is 0.5 ampere. 6 volt, we know 6 volt. 0.5 ampere. R1 is a 12 ohm. So 0.5, 12 is 6 volt. So V12 ohm. So voltage number 2, question number 2. Number 2, what is the potential difference? Number 2. What is the potential difference across 12 ohm resistor? So voltage at 12 ohm resistor, I1 R1. So I1 is 0.5 times 12 is 6 ohm. Okay, that's the question. And we're going to learn, we have learned other questions. We learned question D and E we learned earlier, and question D and E and we learned earlier. Okay, question 8. We learned question 8. We quickly go through question 8. Question 8. Figure 8.1 and 8.2 shows two identical filament bulbs arranged in two different ways and connected to the same battery. The series and parallel. So it's a very clear picture, not very clear. 8.1. Question number 8. 8.1 is series, bulb is series. Bulb is series. 8.2, the bulb is in parallel. Okay, bulb in parallel. Okay. What is meant by electrical resistance of the conductor? Electrical resistance, what do you call it? We call it ratio of potential difference to electric current. Ratio of potential difference to electric current. That is called electrical resistance. Figures 8.1, 8.2 compare the brightness of the bulb. Okay, 8.1. So 8.2 is brighter. 8.2 is brighter. 8.1 is dim. So 8.1. So we can write this one 8.1 and 8.2. So 8.1 is a dim. The bulb is dim. So you must write the words, full words lah. So the bulbs are dimly lit. And 8.2 is a brightly lit. Okay, 8.2 is brightly lit. Okay, and 8.1 is dim. So you must write full words, no. Okay, don't write like this, no. Don't write like this short form. So your bulbs are dimly lit. Bulbs are brightly lit. Okay, next question. Compare the effective resistance of the three bulbs. Effective resistance of 3 bulbs. 8.1, 8.2. For example, I give 2 ohm lah. For example, 2 ohm resistance. And here also 2 ohm. 2 ohm resistance. So I have to find. These are series means we add the resistance consecutively. So 2 ohm. So series 2 ohm 2 plus 2. So this one is RT equals to 6 ohm. So these are parallel resistance. So same resistance. So 1 over RT is 102 plus 102. So 1 over RT is a parallel resistance. So 3 over 2. So RT equals to 2 over 3. RT equals to the reverse way, reverse it. 2 over 3. So 2 over 3 less than 1 ohm. So what do you understand from this? So this resistance higher, this is lower. So is a higher resistance, is a lower resistance. So higher resistance, higher effective resistance. Effective resistance, another word is total resistance. Another word for effective resistance, total resistance. Total resistance is higher. Okay, and the total resistance is lower. Okay, total resistance lower. So then they are asking rating the brightness of the bulb, method arrangement of the bulb, the effective resistance of the 3 bulb, reduce the relevant physics concept. The physics concept is this. This is 4 marks. This is 4 marks. 2 marks each. Sorry, 4 marks. So 5th mark. Okay, when the bulb arranged in parallel. So I'm going to teach you I'm going to give you the physics concept lah. When the bulb arranged in parallel, The bulbs are brightly lit. The bulbs are brightly lit because of a lower resistance, a lower effective resistance. Okay, related to the brightness of the bulb, method of arrangement, bulb and effective resistance. Okay, 3 bulb. Okay, reduce. Okay. So when the bulb arranged in parallel, okay, the effective resistance is lower. Therefore, bulbs are brightly lit. That is called physics concept. Okay, and I told you this parallel only. So you can write for series also. But either one, you write a series or parallel. Okay, if series, you may write like this: the bulb arranged in series. The effective resistance is higher. Therefore, bulbs are dimly lit. Okay, bulbs are dimly lit. Okay, that's the question, lah. Okay, next question. Next question. Question number B. A 10 ohm resistor, 5 ohm resistor is connected in such a way the total resistance is less than 5 ohm, more than 10 ohm, and less than 20 ohm. Draw a diagram to each arrangement and the circuit. Calculate the total resistance. And total resistance of each bulb. Okay. So okay, less than 5 ohm. Okay, question number 1. So you must draw the circuit only, the resistor circuit only. They have a complete circuit. If you ask the complete circuit, you must put a battery and you put a meter. But we put resistor. So these are three resistors. This must be parallel. 10 ohm resistance and 5 ohm resistance and 5 ohm. Because 2 5 ohm resistor and 1 10 ohm resistor. Okay, two 10 ohm resistor. Sorry, 1 10 ohm resistor and 2 5 ohm resistor. Okay, so it's less than 5 ohm. That's question number 1. Question less than 5 ohm. How we know less than 5 ohm? Okay, total resistance. Okay, in resistor in parallel, you must understand total resistance will be lesser than the lowest resistance. 10 ohm, 5 ohm, 5 ohm. So total resistance is lower than 5 ohm. Okay, 10 ohm, 5 ohm, 1 ohm. Let's say 1 ohm. So total resistance will be lesser than 1 ohm. I can prove it to you. Okay, lesser than 1 ohm. Okay, and but we can prove it by this one. 1 over 10 is 1 over 5, 1 over 5. So this 1 over 10, 1 over 10, 1 over 5, 5 times 2 times 2 times 2 times 2. So 10 goes to 2 plus 2 plus 2. So 5. 1 plus 2 plus 2, so is 5 lah. 5 over 10, so 1 over RT. So RT, reverse it, 10 over 5, that is called 2 ohm. So 2 ohm. So total resistance or effect is less than 5 ohm. They want the circuit. They draw the circuit and they want to prove it. Okay. Next question. We want it more than 10 ohm, then less than 20 ohm. The total resistance must be more than 10 ohm but less than 20 ohm. More than 20 ohm, more than 10 ohm and less than 20 ohm. It must be combined circuit. So this is this is 10 ohm, this is 5 ohm, this is 5 ohm. Okay. So series, parallel. So we have to do the parallel first. So 1 over RA, 1 over RA is 1 over 5 ohm, 1 over 5, 1 over 5. So 1 RA, it's not total yet. So 1 over, we are doing only the parallel. So 105, 105. So is equals to 205. So RA. So 1 over RA. So RA equals to 502. So equals to 2.5 ohm. So total resistance, the total resistance will be 10 because series plus parallel. The parallel 2 resistor, the series can become 1. The parallel 2 resistor 5 ohm, 5 ohm. I've done this question before. I've done parallel combined question before. So 5 ohm, 5 ohm. By making two combine the two parallel resistor into one, 2.5. So 2.5. So the total resistance will be 12.5 ohm. So this is more than 10 ohm, less than 20 ohm. More than 20 ohm. More than 10 ohm, but less than 20 ohm. So that is the total resistance. So we have finished these questions, and the rest of the question we don't have questions, and we will see again next class. Next week maybe we start a new topic. Okay. Thank you very much.